If you've worked with React Native, you might have noticed a common complaint. It sometimes feels slow. But is the framework truly the problem? Have you ever wondered why two apps built with the exact same technology, React Native, can have drastically different performance? Why does one app feel fast and buttery smooth, while the other is laggy and frustrating? We are going to dive into the core reasons behind this paradox and show you that the blame shouldn't fall on React Native itself. Here is the core idea. React Native is not inherently slow. The performance issues you see are almost always caused by bad architecture, or, more specifically, blocking the main JavaScript thread. The single biggest reason React Native applications feel slow comes down to a traffic jam on the JavaScript thread. Think of the JavaScript thread as the brain of your app. It handles all the business logic, state changes, and tells the native UI thread what to draw. If you overload this single road, everything stops. When heavy computations run on this single thread, like parsing large JSON objects, running intensive loops, or updating state too frequently, the thread gets blocked. And when the JS thread is blocked, the UI can't update, leading to frustrating lag. Another major source of lag is invisible, unnecessary re-renders. This often goes hand in hand with poor state management. Every state update can trigger a component re-render. If your state is poorly designed, small changes can cause entire sections of your app, the component tree, to repaint again and again, wasting precious processing power. Large lists are a common trap. If you render all 1,000 items when the user only sees 10, you're eating up memory and causing huge performance dips. Proper list virtualization is essential to avoid frame drops. Beyond code and re-renders, the media you include in your app can be deadly to performance. Think heavy images and large app bundles. Using large, unoptimized assets like massive PNGs or JPEGs without proper resizing or compression is a rookie mistake. Loading multiple high-resolution files at once will instantly kill your app's performance and slow down initial load times. A large application bundle means a slow startup time. This often happens due to including too many third-party dependencies, unused libraries, or a lack of proper tree shaking when building your production app. Now let's look at the underlying communication layer and why certain animations cause stuttering. In the old React Native architecture, communication between the JavaScript and native realms relied on a serialized JSON bridge. Too much frequent communication and data serialization across this bridge led to significant delays. Animations tied to the JavaScript thread will inherently stutter when the JS thread is busy. For buttery smooth animations, you must offload them to the native UI thread, ensuring they stay responsive regardless of the logic running in the background. Finally, we address a common area of confusion for developers when testing performance. The development mode, or debug mode, is intentionally slower as it includes extra checks and features for debugging. Never judge the final app's performance while running in debug mode. Always test and evaluate performance using a release build. The apps that feel buttery smooth follow a simple checklist: minimal work on the JS thread, virtualized lists, optimized assets using the new architecture, and leveraging native-driven animations. So remember this key takeaway. React Native is fast. Your architecture and how you choose to manage resources and communication decides everything. Stop blaming the framework and start looking at your code's structure. Optimizing these bottlenecks is the path to truly high-performance mobile applications. If you want a detailed video on how to implement the specific fixes for all these issues, let me know in the comments below.